Hello and welcome to the MMO Development Class Week 12 with me, Nelson, and joining us tonight, a Mr. Jason Busby.
Hello, hello, all right.
Hey. Okay, so last week we left off with quite a bit of refactoring on our server-side code to make it less, well, ugly. Like I said before, the way I'm approaching RuneSlinger is I'm primarily building a game and refactoring things out that could be made a little bit more frameworky as they make sense to. However, I did make a couple of mistakes that I want to go ahead and get cleared up real fast. And after I do that, just because I don't want to do any coding off screen, so they're just little things, little naming things. After that, we're going to start to take a look at CGS, or Cascading GUI Sheets. And that's a project that I put together a while ago where it is a CSS language, or CSS-like language, with a couple of extensions that I've added in that allow you to build GUIs inside of Unity. And it's a very interesting project for a lot of different reasons, but I think the biggest one is that it allows us to get into actual language development, at least insofar as creating a parser and lexer that allows us to understand structured language and apply it to some sort of environment. In this case, that environment is obviously Unity's GUI system. Now, I don't know what's going to happen with Unity's GUI system. It was supposed to be redone a year ago. But at the same time, the amount of code that's specific to Unity that ended up inside CGS was actually fairly minimal, which is good, which means we should be able to apply most of the same code if a major change to the GUI system does happen in the future. But like I said before, the most interesting thing I thought of about this CGS project was it's all about building languages. And building languages is really fun and something that is important for very large projects, especially something like an MMO, where you would want to be able to create your own custom data formats for containing things like quests or items or whatever. And it's going to be important for people to be able to write the code that understands the code that's written by artists or designers or whatever. So yeah, like I said, the first thing that's a sensible introduction to CGS, right?
Yeah, it's a good start. But first thing you need to do before we focus too much of our attention over there is get a few fixes in place back over here.
Just things that really bug me. For some reason I named this namespace command. It should be commands. I can't believe I didn't catch that before. And because I renamed namespace, I'm gonna tell ReSharper to fix it for me. And the second one, I have one more thing to say after I do this, but this should be called Rune Game Component, not Rune Game. And this is a question about terminology, and I've spent a little bit of time thinking about this, but it'd be interesting to hear what other people think about the terminology that I've used for some of the architecture of this application. Just a quick rundown, especially for Jason here, the way that things are currently set up is that our peers receive commands, which is a very common pattern in network applications, and those commands then get handled. The responsibility of the command handlers are to do whatever business logic is responsible or should be done for that command. However, I needed two more layers in order to complete the architecture. The first layer I needed was a service layer, and the reason I needed that was because occasionally code was duplicated between commands. So, for example, our login handler adds a player to the lobby after you log in, but so does the register handler. Does the same thing. So in certain cases, I broke those things out into a service layer, which performs code that might be repeated between commands. The last piece of the puzzle was something that I've been calling components, kind of similar to the way Unity has components where you can attach components onto objects. And the point of these components are to be able to persist data between commands on the server. So for example, my Rune Game component contains all of the state of the rune game. It contains very little business logic, but it contains the state of the game so that it can be shared between different requests. Same with the lobby component, which the lobby component is really just a collection of sessions that are in the lobby. It's not very important. And same with the challenge component, which is used to determine if a current session is in a challenge or not. I'm honestly not sure that I like the name component here. They started off with objects that did have logic in them, but then I moved that logic into the service layer because these objects are longer lived than a single command, whereas the server layer is instantiated per command that requires it. And that's a necessity for being able to inject in our dependencies on things like the event publisher or the database session. So that is one thing that I kind of want people to think about. Just this name component's really starting to get on my nerves. But I mean, that's about it. It's a simple project. It's a simple game. There's not a lot of architecture that was born out of it other than the things that really did make a big difference. Like, for example, ReSharper failed me. Hold on. Okay, good. There's only one. There we go. Yeah, so not a lot of architecture was born out of it, but that's a good thing because we kind of nailed down the most important things. And I like how lightweight it currently is, where pretty much you can just scan down the command handler's namespace and get an idea about everything that the application does. Although a lot of these classes are going to have to be moved out of this project eventually because they're not really business logic. Anyway, so that's really about it as far as the architecture or the changes I wanted to make, unless I'm forgetting something, which I probably am, but that was really all I wanted to do.
Okay, simple enough. Now, when Nelson gets into CGS here in just a minute, if you guys have questions, please make sure to ask them over in the questions panel. Don't be shy, because some of this stuff might get technical, and by asking questions, you guys will keep it from becoming too challenging. So yeah.
Yeah. All right. So CGS, like I said before, is just Cascading GUI Sheets. It allows us to control Unity GUI skins because the editor for Unity GUI skins is absolutely awful, and anybody who has tried to do any large-scale projects with it will get frustrated. So that's kind of why I built it. But I also built it as a fun little project to give me an excuse to write a language. And so what we're going to be doing is we're going to be using a project called ANTLR. Now, what I'm going to do is I'm going to find a browser window, and I'm going to go to the homepage of ANTLR. And wow, they really changed it, didn't they?
Yeah, that's the last time I saw it.
I thought I put you on Do Not Disturb. I guess I didn't do it hard enough. Okay, so what is ANTLR? ANTLR is another tool for language recognition. There's a variety of different things that tools that ANTLR gives us in order for us to be able to understand structured language. And when I say structured language, I mean anything that can be determinately understood by a computer. Like, for example, English is a natural language, which is very difficult for a computer to understand. But we want to be able to write a parser that understands structured language. And I'm going to be using ANTLR, which seems to be one of the most, if not the most popular tools for this sort of thing. There are also other tools such as Yak and Bison, but there are a lot of reasons ANTLR is just more modern of an application or of a framework to use that for. So what I'm going to do, just to kind of give a quick rundown of ANTLR, I'm going to go ahead and download something called ANTLRworks. And ANTLRworks is an IDE, and wow, they really... Oh, nice. I was doing this earlier, but I must have hit a older version of the site accidentally instead of hitting the newer version. Okay, so I'm going to go ahead and I just downloaded a zip. I'm going to dump it into my software. It's just a zip that you just dump somewhere in a computer. Dump that into my software folder and wait a year. Wow. For it to extract. And then I'm going to open it up, give people a quick rundown of ANTLR syntax, and then talk about how we're going to integrate that into C#, because that's going to be the most important aspect to working with ANTLR, is bringing it into the programming environment that you want to work with. Now, I know that this will be a slight review, but actually it's good we're doing this because so many things seem to have changed with this IDE from some of the stuff that is already available in the MMO course. But since I'm doing this now, I might as well use the latest tools available for it. So if it blows up in my face, it's not my fault. Huh, they built it on NetBeans? That's interesting. All right, let's go ahead and create a grammar file. I'm going to create what's called a combined grammar. Everything in ANTLR is described as a grammar file, and a grammar file is a file that's written in ANTLR's own language, which is kind of funny because ANTLR is actually built on itself. The language that powers ANTLR is the language they use to develop ANTLR, which is kind of cool. But anyway, what I'm going to do is I'm going to use a combined grammar. Now, with ANTLR, you have lexigrammars, parser grammars, combined grammars, and you also have tree grammars, which doesn't seem like they have a template for that.
Yeah, we do have, real quick, we had a question that came in, which is a really good one before we get too deep into that. And that is one question about CGS. I know Unity GUI stuff can get a little slow, and you can batch draw calls to speed things up a lot. Are we going to develop this with performance enhancements like that in mind?
Performance enhancements like that specifically in mind. We're not going to develop CGS initially for that. Like I said before, all CGS is 90% of the code base of CGS of what I wrote, and it's actually a pretty sizable project, is completely independent of what it ends up styling. You can use it to style really anything. And so at first, we're going to be building directly against Unity's native GUI implementation, because that's the easiest thing to do at this point. However, just like you can swap a back-end compiler and a front-end compiler if they both share the same intermediate language, you can do the same with CGS, where we can keep all the syntax and all the rules and all the properties, but have it render out to something custom. But that's a completely... That's not what CGS solves, really, in a very strict sense of the word, because CGS is all about being able to define the way something looks using a CSS-like language. What it happens to be defining, what at the end of the pipeline it decides to style, is completely up to you guys. And initially, because it's just a lot easier to build it against Unity's built-in stuff, we'll do that. But I don't foresee there wouldn't be any bits of CGS that would really have to change if a different rendering engine other than GUI's Unity, other than Unity's GUI, were to be used. So hopefully that answers that question. Or did I completely confuse you too, Jason?
No, actually, that makes sense.
Okay. Okay, so ANTLR allows us to describe a language. And what it does is once we describe the language, ANTLR then emits code that will compile in any of the target languages that ANTLR supports. Off the top of my head, I know ANTLR supports C, C++, Ruby, C#, obviously, otherwise we wouldn't be able to use it, and Java. I think it supports a couple other out of the box, and I know there's extensions for other languages.
And then speaking of support, Alberto said that reading before the ANTLR site, it seems that ANTLR 4 does not support C#.
If it doesn't, we'll use ANTLR 3, but I'm sure that there would be an extension for it, because a lot of C# projects are written on ANTLR, which is in fact, great. You see that?
What is it?
You see how
the
window?
Wow! Yeah.
The window is over here, but yeah. There we go. Let's check this out, because I haven't used ANTLR 4. I used ANTLR 3. ANTLR 4 is a very new product. Let me quickly glance at it and see what it says about C#. let's see here. There should be a runtime libraries and code generation targets, Java, C#, C++. Now, it doesn't seem like there's a whole lot of documentation. It looks like this is very new, January 21st, 2013, which is funny because that was my 21st birthday and the launch of the new 3D Buzz website. That's kind of funny. It seems it does support C# though. So we'll check it out. That's why I wanted to play with ANTLR Works first. Let's see if ANTLR 4 works the way that it should. Otherwise, we'll use ANTLR 3. But the nice thing about, I mean, although I do want to use the latest technology possible, the nice thing about ANTLR 3 is it's very stable, very mature, and widely used in the .NET community. So we'll see what happens when we start playing with some combined grammars, which leads me back to how ANTLR works. So with ANTLR, you have grammars. Grammars are your ANTLR source code. And then ANTLR is a program that takes your grammars and turns them into code in any target language that you want it to, that understands the language that you described to ANTLR through the use of a grammar file. So if that didn't make any sense, let me go ahead and hit next. Let's give this CGS, and I don't want to dump it in my users folder. I want to dump it somewhere else. Let's dump it in another place on my hard drive, if I even can remember how I organized this stupid thing. Wow, it doesn't like enters, does it? 3D Buzz, projects, new folder. There we go. All right, and I'll hit finish. All right, well, that looks pretty much what I expected it to look like. Everything, like I said, everything in ANTLR is a grammar, and we have these little grammar files, in this case a combined grammar, and what a combined grammar is a selexor and a parser. Now, a lexer is something that takes text and turns them into tokens. So, for example, if you were to give a lexer, now keep in mind a lexer is dependent on what language you're writing. A lexer that was written for C++ would be different than a lexer that was written for Python. But let's say, let's just actually use CGS. So I'll say test color red. So what would a lexer do? Well, a lexer would take this text and turn it into a stream of tokens, and it would strip out all unneeded things such as white space. So we would start off with a dot, and then an identifier with the value of test, then with an open curly, and then with another identifier with the value of color, with a comma, then another identifier with a value of red, then a semicolon, and then a close curly. So the whole point of a lexer is to take this text and turn it into a stream of tokens. In ANTLR, parsers can do a variety of different things. Color comma or color colon. Colon. Thank you. So that's what a lexer does. That's all a lexer will ever do in ANTLR. But parsers can do a variety of different things. They can execute arbitrary code as they walk down your syntax tree, or they can translate a stream of tokens into what's called an abstract source tree, or an abstract syntax tree. That's what we're going to have it do. We're going to have our ANTLR parser take this stream and turn it into a tree for us that we can then understand. So what I want to do on top of my token stream is to give semantics to our language. What I mean by that is I want to do something like let's say rule set, which is just an arbitrary token that I made up that's specific to the language. So I'll say rule set, and then what do I want to do? I want to have a list of selectors. The first one I want is a class selector with the value of test. Notice how I'm nesting this. Then what I'll have is a list of properties, and the first property has the value of color or the name of color with the value of red, and then n paren, n paren. So the whole point of the parser is to take this and turn it into something like this. Then, like I said, this abstract syntax tree is dependent or specific to the language that I'm actually writing. With this, I can then go on and do further transformations on it. But it's just a lot easier for me to work with this intermediate step. So let's look at some awesome ANTLR action. What I'm going to do is the first thing, I'm going to go ahead and make sure that we can get this to compile to C#, otherwise we'll drop back into ANTLR 3. So I'll start off with saying something like, let's go ahead and define a token. So I want to define an ident token. Typically, I define ident tokens with ident start, ident mid as many 0 to many. Ident start, so the start of an identifier, just like most languages, like even including C#, the start of an identifier is going to be a variety of different things. So we're going to start off with potentially an underscore, anything that's valid as an identifier except for a number, basically. And I'm actually going to define this as a fragment, which it seems like ANTLR still supports, so that's nice. So we'll have a fragment, ident start. I'm going to actually change the way I'm doing the syntax a little bit. ANTLR is a white space insensitive language, so I'm going to choose to write it like this. So we'll have a fragment of ident start. We'll give it, wow, it's indenting like crazy right there. We'll give it the value of an underscore or a letter, which I haven't defined yet. Notice how I'm working my way towards describing my identifier bits and pieces at a time. Then we need our ident mid. An ident mid is going to be the value of an ident start or a number. And I believe the syntax will do that. No, it's just 2 dots. Okay, the next thing we have to do is we have to define what exactly is a letter. Well, a letter, and I'll explain what this is in a moment once I get a working example so you guys can actually see this run against something. A letter is going to be A through Z or capital A through capital Z. Okay, finally we have a thing. Syntax error missing. Oh, I'm missing a semicolon right there. And then we have a CGS has no rules. Let's go ahead and give it a test rule of ident star. Okay, let's test this out and I'll walk through what exactly all this does. Let's see here. Sorry, I just need to find there should be a thing called, at least in the previous version, there was a thing called an inspector. There's a Lexer debugger window, which that sounds like fun, but it's not what I want. What do these buttons do? I don't know. Let's see. Edit, view. Let's view our, no, run tools, Windows. Should be in Windows somewhere. Syntax diagram. That will actually be a little bit helpful, but am I seriously going to have to look at the documentation on this program? Services? No, those are just our rules. Those are our services. I don't want those. Navigating, versioning output, property services, favorites, files, syntax diagram, Lexer debugger controller. Is there not a run button up here? Oh, come on. Jason, help me.
Okay.
my run button is grayed out. Why is it grayed out? Maybe I need to create a project? Because I saw something about creating a project in here. Ooh, run in the test rig. That sounds like fun. Input. Oh, it wants an input file. Okay, well, let's just do that then. This will give us what I want in order to be able to demonstrate what we're doing. The previous ANTLR had a nice little interactive window thing that was really cool. It seems like they didn't implement that with this for some reason, but that's fine. Because what I can do is I can create a test.txt file, and I can put in something like whoa and hey, and this will allow us to look at how our lexer works. So now I have to point the input file to that. Then I don't want to quote it. I don't know if it'll blow up if I quote it. Then I'll set the start rule as test rule, and then I will try to hit finish, but it's grayed out. Now it's not grayed out. This thing's buggy. Grammar, CGS has no rules. Yes, I do. You're lying to me. Okay, let's try to run this. And now run is grayed out again. Now it's not. Wow. What? What? You see what this is the dumbest window I've ever seen in my life. As a slider, and I can increase or decrease the font size. Okay. All right, I might have to be dumb. I might have to jump back into the other version of ANTLR Works that isn't so buggy, because as you guys can see, this program seems to only work half the time. So that's fine. This class is an adventure for everybody. So what I'm going to do is I'm going to jump into ANTLR Works 1.5, which uses, ooh, don't look at that, which uses ANTLR 3, and I'm just going to say open, and I'm going to point it over to somewhere, or create a bunch of folders on my desktop. Either way, that works. Okay, any questions? And it figures this is the class that Jason jumped into. But again,
It's all good.
things have been going actually really smoothly for the last 12 sessions, so I'm fine with a little bit of a problem here and there. If I can find my documents folder, then we can get back going. And we can actually use a product that I know works, as opposed to a product that seems to be buggy. Here we go. This is the thing that I was talking about, and I have my interpreter. All right, so getting back on track, I guess we're using ANTLR 3 for now. I'll check out the release notes of ANTLR 4 later and hopefully find a version of the new ANTLR Works that doesn't completely break. But I'll go ahead and start off with test whoa hey. And I'm typing that into my interpreter window, and I'm going to apply it to the test rule, and I'm going to hit run. Okay, I seriously do think that we're getting trolled. Alright, best thing to do when that happens, that actually does happen sometimes with this product, is just restart it and hit run, and we get interpreting hold on, we do have some errors reported. Here we go. Decision can match inputs such as end of term using multiple alternatives, 1 or 2. So let me go ahead and evaluate my syntax real fast. Test rule is 0 to many of idents. I'm actually going to change that to a plus. And then I'm going to see what happens. Errors reported in console. Let's see. CGS line 20. I don't know what line 20 is. Is there an ident start? Ident start is an underscore or a letter. A letter is A through Z or A through Z. That is correct. Ident start, then fragment ident mid is 0 to many ident starts or there we go. It looks like I actually made a little small mistake in my ident mid, which I do just to see if that was what was causing the problem with this guy.
Good, because I was actually curious about that myself.
Let's go ahead and try this one more time and see what happens. Run and test rig, test rule, finish. Missing ident.
Did you also change the asterisk, or you change it back to a plus?
It's still a plus.
Oh, wait, no, it's still a plus.
And I removed the asterisk from that, which obviously that did confuse it. And okay, looks like this could either be a difference between ANTLR 3 and ANTLR 4, or it could be a bug in ANTLR 4. Either way, I don't want to spend too much time playing with that on screen. I'm curious about it, but I would rather go with what works and get everything back on track. Okay, so here is our grammar. Now this is what's called a combined grammar, which means it contains a lexer and a parser. So far, we do actually have a lexer and a parser. This is our lexer, and this is our parser. The way we know the difference between what is part of the lexer and what's part of the parser is that these rules, they're called rules by the way, are capitalized. Because they're capitalized, they're understood by ANTLR to be lexer rules and not parser rules. Whereas in this case, ANTLR understands that this is a parser rule because it starts with lowercase. And you'll actually see that on the left-hand side here. We have parser rules and then lexer rules. So we need at least one parser rule, and this parser rule just says, I want to match anything that is one to many identifiers. Now, what's an identifier? Well, we can jump down to our lexer rule. Remember how a lexer, all its goal is to take text and turn it into a stream of tokens. And that's what we're doing. By defining a rule called ident, anything that matches this becomes an identifier token. So anything that matches this rule right here will be considered an identifier token. It's important to realize that this process happens before parsing, meaning ANTLR has to determine if something's an identifier without knowing where it appears within the parser rules. So that's a very important distinction. Now, our lexer rule ident says that an ident starts with an ident start and ends with an ident mid. Now, I define three fragments, but I'll start with these two. Two fragments, ident start and ident mid. What's a fragment? Well, technically, this would probably, actually, I don't think this will work if I take off the fragment. Let me explain why. Okay, it still wants to work. But we are getting, hold on, sometimes the console doesn't get cleared out properly. Yeah, it's still wanting to work, but we don't want this to work. And the reason we don't want that to work is because, actually, I wonder if I just put a D there. Yep, there we go. Can anybody guess why now that I've removed the word fragment from these lexer rules, adding a single character identifier to my stream results in a no viable alt exception or no viable alternative exception? The reason is, comes back to what I was saying before. The parsing or the lexing happens before the parsing. So when the lexing happens, the parser or the ANTLR has no concept of where those lexer tokens appear within parsing rules, which means ANTLR cannot distinguish between a letter or an ident. Or an ident mid, actually. It's getting confused between all three of these rules. It doesn't know which one I want when I just have a single character. So that's why you put in fragments. Fragment simply says that we want to be able to reuse this lexer rule over and over again, but we don't want ANTLR to ever match against these rules and use them as tokens. So now that I've added fragment, I can hit run, and it properly detects D as an identifier. So hopefully that makes sense to everyone.
So take a look over in BuzzNet real quick.
So what happens if we put numbers in the input? Ident mid means G's 00G will work, but 00GG shouldn't, right? Yep. 00GG should throw a no viable alt. Or not. An ident start is a requirement. Ident start is either that or a letter. Or actually, hold on. I actually need to use the debugger to test this because I think it's matching as a token but not as the right type. So what I'm going to do is I'm going to say run debug. And wow. Use parser.java. Give me 1 second. I'm going to look on my file system to make sure. Actually, no, I think that I never hit generate code. There, good. I generated it. Now debug it with the text of this, and I'm going to hit OK. And now I'm running through what's called the debugger, which is a lot nicer than... Oh, everything just absolutely hates me today. Hold on. I'll talk about that in a second. Generate code. We've generated the code. Now debug it. And we get javac file not found CGS parser.java. What happens if we just run it? Nothing? Of course. You just had to ask. Yes, indeed. Hold on. Wow, seriously? There's a to-do in the comments of this. I'm going to see if I can run jar files in compatibility mode. I don't know if you can. That wouldn't make sense if you could. Ooh, it was blocked. Windows blocked it, which means it probably had difficulty reading and writing to the file system, which probably would cause it not to debug. Or not. Close enough. Let's generate harder. Grammar has been successfully generated. Let's hope it was actually successfully generated. And we get this again. Find simple new CGS. Unfortunately, we can't see exactly what type this token is. Okay, there we go. We can see what exactly type this token is. It's an identifier with the value of 90432 ADS, which shouldn't have been matched. Ident mid, ident start. Actually, I think that potentially what I'm running into is something about You know what I forgot?
What's that?
I forgot white spaces. I need to hide my white spaces, I believe. So let's go ahead and... The one thing I hate about this program is it decides to indent everything completely wrong. White spaces. What are white spaces in my language? I'm just going to define them straight up for you guys. They are tab characters are white spaces. Spaces are white spaces. Carriage returns are white spaces. New lines are white spaces. And there could be any number of these, so I'll say plus. Then I'm going to do something special. I'm going to say channel equals hidden. And we still get an identifier. Yeah, problems that you might run into include things completely not working. Here we go. We are receiving some sort of error here. Which I believe could be an indication, or could be as a result of this. Let's see what happens when I run again. Nothing happens, but if I add that, we get no viable alts. Now, for some reason, it looks like my interpreter is not displaying my no viable alts, which it should. Does the fragment option let the ident start part of the ident be optional, so it doesn't actually require an underscore or letter? No. Ident start, the reason why ident start, you can start with an underscore or a letter is because of this pipe symbol right there. The pipe symbol is what's telling it that it can either be an underscore or a letter. And it's still succeeding and parsing this for some reason, even though it shouldn't. But it's a fragment, so could it be nil? No. It can only be null if I specify it as optional. And you specify something as optional by putting a question mark at the end of it. However, that's going to confuse everything. Yep, I get a bunch of errors reported. As a result, alternatives 2 were disabled for that input. Which, now the interpreter is very forgiving, but the actual ANTLR runtime is not, which is why I wanted to show you guys my generated code. Let's see if it even generated that code or if it's just lying to me. I hope it's not lying to me. It is generating that code. Okay, I'm going to delete the generated code and I'm going to generate again. And it did generate it. So let's hit debug, hit OK. Hold on. I'm going to disable my firewall, which it shouldn't be blocking internal connections, but it's saying that it's having an issue. Okay, connecting with the remote parser. And it's still not wanting to run it. Okay, let me go ahead and turn back on my firewall. Alright, so that's something to look at in the future, but let's go ahead and get back on track. We have, although our interpreter is interpreting this as an identifier, it shouldn't, and if you were actually using ANTLR inside of your code, what you would get is an exception. Specifically, a no viable alt exception. Now, for whatever reason, the interpreter is not showing that to me. But that's okay. We don't need it for that. The point of me showing the interpreter is that we can now quickly write out some ANTLR rules to get some basic grammar going. So we have a test, then another identifier, then another identifier, and those are being properly understood. White spaces are being ignored. They're being ignored because anything that matches this token is placed on the hidden channel, And the hidden channel, like its name implies, hides it. So what I'm going to do now is, now that we have identifiers, I also want to allow for dashes, because in CSS, identifiers can also start with dashes, unlike most languages. Because right now, I believe this will do something dumb. Yeah. Right now, I want this to be treated as a whole identifier, not as two identifiers. So to add that rule in, I know this isn't an academic approach to learning ANTLR. It's more of a, hey, I now need this, see what code I have to write to do that sort of way. But ANTLR is very large. There's a lot of fun stuff you can do with it, and going an academic approach will take forever. There have been books written about ANTLR. So what I'm going to do is I'm going to change my rules so that they can have dashes in the identifier, parser, or lexer rule. And to do that, I need to alter my ident start to also allow dashes. And I need to alter my ident mid to also, actually I don't need to, I changed the ident mid because the ident mid is written in terms of the ident start. See how nice fragments are? Now that I hit run, look at that. We now have a single token. Hey, can you really believe that, Jason? Something actually worked. Okay, so now we have our test rule that just says we want a bunch of identifiers, but this isn't very useful. I first want people to understand what they're looking at in the interpreter window. What they're looking at is the parse tree, which is how ANTLR went about matching our rules. And it's very useful for the beginning of development, but as development you start working with ASTs, the debugger is actually what you want to use. Unfortunately, I can't seem to be able to use the debugger. Actually, I wonder if debugger, change the port. I wonder if that port's being used by someone. Because I've actually used the debugger quite a bit in the past. It's a very, very powerful tool. And no. Okay, so we'll go back to the interpreter. And let's start off with trying to match some syntax that we want to match. Keep in mind, our goal right now is to have our parser and lexer understand our language. We're not necessarily doing anything with the language yet. We will in the future. At the moment, we just want it to understand the language. If you guys have ever written regular expressions before, you know the first goal of writing a regular expression is to be able to get your regular expression to match what you want it to. After you have that, then you add in groups that you can capture and all that fun stuff. So I'm going to write in some code that I would consider to be valid CGS. There. I consider this code to be valid CGS and I expect it to be parsed as such. But if I hit run, we get this. Now, it did actually get pretty close to what I wanted it to be, although it left out a couple things that are required. Is it just me, or was the problem where the dashes were part of the tokens before you added this similar to the problem with the numbers being allowed at the beginning? Kind of. The interpreter isn't as powerful as a real ANTLR debugger, and as a result seems to get confused easily, like what we're looking at right now. Technically, this did not parse, even though the ANTLR interpreter gave us some output. But we know it didn't parse correctly because if we look at our errors, we see a variety of no viable alt exceptions. Particularly, those errors are going to pop up whenever anything that isn't an identifier gets parsed. So let's start off with some rules. What I'm going to do is I'm going to create a style sheet rule. Now, a style sheet, if I can get it to indent in a way that doesn't drive me insane, a style sheet, per the specification of CSS, is 1, 2, 3, 4, a collection of rule. And a rule, you may have 0 to many rules. Now, what's a rule? A rule is two things. It is a list of selectors, or a selector that's broken up into subselectors, and a listing of properties. So let's write our rule. Our rule looks something like, or should look something like, if that indentation. Our rule will look something like it will want to find selectors, an open curly, a list of properties, and then a close curly. So let's do that. I'm going to say selectors. Notice how I'm just throwing out random new rules and then defining those rules as I go along. I want my ANTLR rules to be very short. It makes them a lot easier to debug and understand. The next thing I need is an open curly. However, we don't have an open curly token yet. So, because I just ran into something that we don't have yet, I'll go ahead and define that really quickly. And I'll define that in terms of what are called tokens that appear in the top of the file. Tokens are a shorthand way of defining Lexer rules that match single characters. So what I can do is I can say O curly equals open curly, and close curly equals closing curly. So now I have my open curly and closed curly defined. So once we open up a curly, what do we need? We need a listing of properties. And now what's a property always going to be? Well, a property is always going to be a identifier followed by a colon followed by a value. So let's do that. We need an identifier followed by a colon, which we haven't defined yet, so let me go ahead and define that. Followed by some sort of value. I'm going to break the concept of a value into its own rule. Next up, we can have as many of these as we want. Oh, also, they must end with a semicolon, which I need to define as well. We can have as many of these things as we want. That's why I have, for example, two properties, one saying color red, the other one saying background blue. We want to be able to have as many of them as we want, and they're delineated by semicolons. So what I'm going to do is I'm going to put a star there. That tells ANTLR that I want this expression to be able to repeat itself as many times as it can. Finally, our rules always end with close curly. Okay, I'm going to delete test rule, by the way. We don't need it anymore. Now we have two more rules to define. We need selectors and value. Somebody asks why star and not plus. The difference between star and plus is a plus is 1 or more, whereas a star is 0 or more. Technically, according to the CSS spec, a rule that has no properties inside of it, although fairly useless, is still valid. So that's why I'm allowing for the possibility of there being 0. There's no reason why I shouldn't be. Well, why did you just do that? There's no reason why I shouldn't be able to. Okay, let's look.
You had another question over there too.
For consistency, shouldn't we have tokens for underscore and dash? If you wanted to. The reason I guess I didn't do these because blah blah is because they don't appear anywhere else. If they do appear somewhere else, then I'll turn it into a token. Or if I need it for some reason, then I'll turn it into a token. But for right now, because they only appear in one fragment, I'm just not going to bother with it. I do happen to know that open curlies and colons and semis will appear more than once the grammar gets a little bit more complicated. So selectors. The first thing I'm going to do is I want to define a basic class selector. So selectors is the thing about selectors in CSS is that you can have as many as you want separated by commas. So what I'm going to do is I'm going to first define a comma. Then I'm going to say a selector is a selectors. Notice how this is pluralized. Is a selector and a comma selector repeated as many times as necessary. So what's a selector? Well, right now we only have one selector that we're implementing, and that's a class selector. So what I'm going to say is a selector is going to be a class selector. The reason I'm breaking it up this way will make sense, and if you know CSS already fairly well, you'll understand why I'm breaking this up this way as well. What's a class selector? A class selector is simply a dot followed by an identifier. What's a dot? A dot is a period. So now we have our rules. A rule is selectors followed by an O curly followed by properties. A selectors is one to many different selectors delineated by commas, and then a selector is just a class selector for now. We'll add different kinds of selectors later. And a class selector is a dot followed by an identifier.
Now, you've also had 2 questions come in over in BuzzNet.
But you could have said O curly ident. Your asterisk is on the wrong side, but I could have, yes, I could have not, wait a sec, my asterisk is on the wrong side. How did that happen? I could have swore I wrote it, blah, blah, blah. Yeah, so what we need to do, what we could do instead is, instead of using colon, we could use that. When, I guess, it's really a stylistic thing. I guess what I want to do is, actually I don't think we could. Or maybe ANTLR will understand this. Yeah, ANTLR will understand this, but I don't like it to. And the reason I don't like it to is because I want all of my tokens turned into tokens that are named. However, inside of Lexer rules, that doesn't matter, because a Lexer rule is something that takes a piece of text and turns it into a token, whereas a parser rule is something that takes a bunch of tokens and turns it into something else. So I really do like my parser rules to not have any strings in them, and I like to keep the strings down in my Lexer rules. Okay, the last thing we need to do is define a value. Now, there's many different types of values in CSS, but we're going to start off with the most basic one, and that's simply an identifier. So now if I run this, hold on, let me clear out my errors and run this again, and we get no errors, and we get this parse tree. Now that's starting to look really good. We have our style sheet, and then we have a rule inside of our style sheet. A rule has selectors. There's one selector, and it's a class selector, which is a dot followed by a test. Then we have our open curly, our color colon value semi, with the value of being red, and we have background colon value, blah, blah, blah. So that's all a bunch of fun stuff. Let's go ahead and add in an ID selector. What happens if we do this right now? Well, there we go. It's finally starting to report errors again. We get a no viable alt exception. And again, no viable alt stands for no viable alternative. Did I mean to move the asterisk under rule? I meant to move it over here, because that's where it should be. The expression that I want to repeat multiple times is this. Otherwise, if the asterisk was anywhere else, it wouldn't work. But anyway, we get a no viable alt exception. The reason we get that is because we cannot, the only type of selector we support right now are class selectors. But we also need ID selectors. So I'm going to say or ID selector. And what's an ID selector? Well, an ID selector is a selector that selects on IDs. And the syntax of them is going to be hash ident. Now hash I'm going to define up here. Now if I run this, we get an ID selector. So that's awesome. Let's try multiple selectors. So I want a test or an ID selector. Now if I hit run, check this out. This is, we got an error. Or maybe we didn't. Hold on, let me clear it and run it again. Nope, we didn't get any errors. So as you see, my parse tree is starting to get a lot more structured and a lot nicer looking. So we have our rule, or more specifically, we have 2 rules. This rule has 2 selectors that are separated by commas. Things can get a little bit more interesting with CSS because we can actually also separate rules with, or hold on, let's go ahead and do element selectors first. Let's say I wanted all H1 elements to have the color of blue. Well, this is going to throw a no viable alt exception because I don't have ID selectors yet. or element selectors yet. So let me define an element selector. An element selector is an element selector that's properly named is probably the simplest selector that you can parse ever. Simply an identifier. So now I want to be able to support element selectors. So a selector is a class selector or an ID selector or an element selector. Now when I hit run, check that out. We have an element selector. But let's say I wanted to parse all, or I wanted to apply a rule to all LI elements that are under ULs. Ooh, we got more errors. Nope, we didn't. See, as I type in this window, it's constantly recompiling, and if I introduce an error anywhere, it'll toss errors in the window, which is kind of frustrating, but it does it. Okay, so now if I hit run, I'm going to get a no viable alt exception. That's because I am not providing multiple selectors here, I'm providing a nested selector. So now we have to figure out how we want a child selector to work. Well, that's where things get complicated, or start to get complicated with how we have our grammar set up. But I do want to support this before, or support this use case before we jump into C#. So let's think about it. We have selectors that can be separated by a comma. Well, I suppose the easiest way to implement this could be just to make the comma optional. Well, there's two ways. I can make the comma optional, or I can make the selectors recursive. I actually want to make the selector recursive. The reason I want to do that is because my parse tree will look a lot nicer. Because I want multiple selectors to be higher up in the parse tree. I don't want multiple selectors to get confused with my concept of what a child selector is. So let's go ahead and rewrite this a little bit. I'm going to change this concept of a selector to a selector type. Then I'm going to change the concept of a selector to a selector type followed by one-to-many child selectors. Now, what's a child selector? A child selector is, if you guys know CSS, is a selector or a selector relationship followed by a selector. Now, this is where things get complicated because a selector relationship, if you guys know CSS, we can have a white space here, or we could have a greater than here, or we can have a plus here. And that's considered to be the type of relationship that one selector has to another. This is a sibling relationship, this is an immediate descendant relationship, and this is a descendant relationship. I'm only going to support descendant relationships right now. And the reason that is because, for a variety of reasons, we actually have to jump into some C# code to get immediate descendants to work. So a child selector at this point in time is just going to be a selector type. In the future, it will be a, oops, it should be child selector here. In the future, we'll have a selector relationship there. Let's clear all our errors and hit run again, see what happens. Okay, so now we have a rule that has a selector, and it has a selector type, element selector, then a child selector, selector type, element selector. So that's the parse tree that I want to see. Solution, CGS doesn't support attributes. There's no reason for me to have attributes on elements. And as a result, I don't support selecting things by attributes. The question was, in CSS, you can do things like, well, what if I wanted to select every single button that's disabled? I could do this. If I wanted to. And this would select every single button that was had the disabled attribute on it. But because CGS doesn't have the concept of attributes, there's no reason to provide that in CGS. Attributes are a very HTML-y type thing, and I don't see any reason other than what we're going to do with pseudo selectors here in a moment. Which on that note, let's go ahead and do pseudo-selectors. So what's a pseudo-selector? Let's say I want every li that's hovered over, and then I want to select the a tag underneath it. Now this colon hover is called a pseudo-selector. It modifies the way a selector works based off the state of the element. Now CGS will support two pseudo-selectors: active when something's being clicked on, and hover when something is being hovered. In fact, this is one of the most powerful features of CGS right here, because with Unity GUI skins by default, you can only change something's properties if they are the immediate thing that's being hovered over. But with CGS, you can change something's properties if it's a child of something that's being hovered over, which provides you with a lot of flexibility. But right now, our rule set won't handle this. As you notice right here, it says no viable alt selection. Is it odd to feel it says one-to-many but use an asterisk instead of a plus? I thought he said that an asterisk was 0-many. Yeah, an asterisk is 0-many, a plus is 1-many. Sorry, I might have said the wrong word somewhere. Okay, what's a pseudo-selector? Well, a pseudo-selector is a word that I have to make sure I'm spelling correctly, because I actually managed to misspell this word so consistently in the last code base that it never made a difference. But when the code was reviewed by somebody, I guess it irritated them enough where they fixed it all. Okay, so now I have the word pseudo on my clipboard. We can go ahead and implement pseudo-selectors. A pseudo-selector will appear after a selector or a child selector. So we'll say pseudo-selector or pseudo-selector question mark, because we might be hitting a pseudo-selector, might not. And a child selector is a selector type followed by a pseudo-selector. What's a pseudo-selector? Well, it's pretty straightforward, actually. All it is a colon followed by an identifier. And take a look at that. We have a rule, we have our selectors, we have one selector. However, this one selector has three distinct aspects to it. The main selector and two child selectors. And then our child selector has a pseudo selector of the hover state. Why only hover and active? I'm lobbying for focus. We can throw in focus later, but I don't want to deal with that right now. The way focus works in Unity makes my brain hurt. And I don't know if we could implement it in a way that would make sense. Anyway, this is actually quite a bit of cool stuff right here. I hope that so far ANTLR seems fairly not intimidating to people, because if you just walk through everything line by line, it starts to make sense. I mean, and then especially with the interpreter, where we can actually take a look at, hold on, are these errors caused by the interpreter or are they caused by something else? Nope, we're getting no errors in the interpreter. But yeah, it's a basic feel, it's easier than making parser myself. Exactly. It's very, very quick to get started. Now, we are going to maybe start off with some more fun stuff here in a moment, but I think right now is a good time for a quick break.
Yeah, probably so. It's been a while. At least you've been running smoothly for the last, 20 minutes or so. It's a good thing. It's a good thing.
Well, again, I justify it in saying that this first major explosion that that we've had in the last 12 sessions.
12 weeks. Understand.
Okay.
Okay, guys. So let's go ahead and take a quick break, and we'll see you back in 10 minutes. Make sure you pause the video, Nelson. Do it.
All right, we're back. Now, the grammar is not complete at all. Currently, we only support identifiers and some basic selectors. We don't support nested rules yet, and blah, blah, blah. It doesn't do a whole lot. But I want to leave people with something fun. I want to get this into a C# project, and I want to fire up a basic test project that we can use to finish our grammar and start looking at building out trees. So I want to get a sort of end-to-end solution as quick as possible, so we can start taking advantage of more advanced ANTLR features that are not available with the interpreter. Now, when I initially developed CGS, I made heavy use of the debugger which did support these features, but since I can't get it going, let's go ahead and get this stuff into C# land and see about, well, getting some fun stuff. Actually, I do want to test one more thing. I want to change it from cgs.g4 to cgs.g. And I want to see if that could possibly be what's causing my debugger to break. Because I really do want my debugger. That's my favorite feature of this. And if this doesn't work, we'll just, whatever. We'll get this into C# and we'll get some proper debugging action going so that we can start off next week and get some more use some more advanced features of ANTLR. Like I said before, our whole goal is to turn something like this into something like this. So let's get that going. I'm going to go ahead and start up a new Visual Studio solution called Cascading GUI Sheets. Make sure I spell that right. And wait a year for Visual Studio to get going. But at least it doesn't break as often as that ANTLR thing. Alright, new project. I'm going to go down to other project types, Visual Studio Solutions. I'm going to create Cascading GUI Sheets. I'm going to place it in a folder that makes more sense than my garbage folder. And then I'm going to hit OK. Next thing I'm going to do is I'm going to close out down Visual Studio, and I'm going to jump into my File Explorer, and I'm going to fix this. So I'm now in the folder that Visual Studio just created. I'm going to hit New, then I'm going to type in Source, and place this into Source. And then I'm going to create another folder called Lib, and I'm going to grab some ANTLR binaries and dump it in lib. So ANTLR. So here's oh, Chrome just did it again. Oh God,
That's really bizarre.
I don't know why everything hates me so much today.
I don't hate you now.
Okay, well that's good.
I bought you lunch today.
Yeah, it was good lunch.
It was.
All right, I'm going to find out where do you download version 3? Come on, there. Looking for ANTLR version. There we go. This is the home page I remember. So let's go ahead and grab ANTLR version 3. I'm going to grab ANTLR 3.5 distribution. That should be fine. Wait for that download. Open it up in 7Z, which I thought I had set as default for that. Then I have ANTLR 3, ANTLR 3.5. We have our tool. Wait a sec, I don't think this is the distribution that I wanted. Because we have our runtimes. Yeah, this is the source distribution. I don't want the source distribution. I want the binaries. Give me the binaries. Why is it so hard for open source projects to provide binaries? There's a port. I believe the port is what I used. Actually, am I just that blind? Why do things have to change, Jason?
Well, Nelson, change is inevitable.
Unfortunately, it seems to be. Because I'm looking through this entire... I do already have just quite a few distributions already downloaded, but I want to show people where they can grab the version that I'll be using. Okay, this is a jar, but I don't want a jar. Okay, let's just grab my ANTLR version 3.1x binaries for .NET Framework. Oh, I think this looks like the one I want. Yay. Okay, so I just downloaded the correct one because they moved it around for whatever reason. I'm going to create a folder called ANTLR. Inside my lib folder, and I'm going to extract everything down into it. And what do we have? We have our ANTLR3.exe. Our ANTLR3.exe is what's going to be generating our C# files for us. So let's go ahead and move this off to the side. I'll be copying that code out in a moment. Let's go ahead and open back up the solution that I created. Now what I'm going to do is I'm going to create a compiler project and a test project eventually. There we go. So let's go ahead and add a new project. I'm going to make it a class library, and I'm going to call it Cascading GUI Sheets.compiler. Or how about CGS.compiler? That's better. Okay, here's our compiler project. This is going to contain the code that ANTLR will generate for us. It's also going to contain our G3 and our other things. So I'm going to add a new item. I'm going to create a code file, and I'm going to call this cgs.g3. And then I'm going to find that ANTLR builder thing I had open, copy, paste it down here. I'm going to capitalize CGS because the grammar name has to match the file name. That's ridiculously redundant, but it's what you have to do. Then, now that I have cgs.g3, I now have to compile this into a C# file that will represent all my stuff. So to do that, I'm just going to go the easy way out for now. Fire up a PowerShell window, and I'm going to go lib ANTLR, ANTLR3.exe. Then I'm going to pass in source cgs.compiler cgs.g3 and hit enter. And I'll see what happens. What we get is a bunch of Java files. Okay, what that means I have to do is I have to go and inform the ANTLR compiler that I am using C#3, or the C#3 interpreter. And then I also want to pass in my output folder, because I don't want to use that output folder. So the first thing I'm going to do is back in my grammar, I'm going to say output equals AST. I believe I do language equals C#3. Please don't kill me if this isn't the right syntax. And here we go. We get a cgs.tokens file, a cgs__g file, and a lexer and a parser file. So that's great, but I kind of want this to be in a different folder. So I'm going to delete these again. I'm going to create a new folder, and I'm going to call it _generated. And _generated is going to, well, it's going to contain my generated code. So to specify that I want to build into the generated folder, I go back into PowerShell and I say this, and then I go ahead and do ANTLR3.exe -o, and then I pass in source cgs.compiler generated. Hit enter, wait a year, there we go. So the final step is going to be to add the generated files to my project. So I'm going to go back into Visual Studio. I'm going to click this little button up here called Show All Files. I'm going to right-click Generated, and I'm going to say Include in Project. Now I have a lexer, and I have a parser. So the lexer and parser were generated by ANTLR. And now what I'm going to, and if you read through this code, it'll actually make pretty close sense to what you're used to, or what you would expect. For example, I could look up my my ID selector, for example, my ID selector, or not, this is the lexer, not the parser. Derp. ID selector, here we go, which is a method that matches my hash ident. So that's really nice. However, you'll notice there's a lot of red in here. There's reason there's a lot of red in here is because I didn't forget to, I just didn't add my runtime libraries to it. ANTLR depends on an additional file or an additional assembly in order to work. That additional assembly is located under lib, ANTLR, and then antler3.runtime.dll. I add that reference in, and all of the errors go away. By the way, I learned this the hard way. If you have the Visual Studio Achievements plugin, it will think you wrote this code, and you will get a lot of a lot of really bad achievements for having horrible code.
It will hate you.
Pretty much. But all the errors went away except for one, it looks like. Ooh. Oh, this is wonderful. Forgot about this one. Guess what? The Java, whoops. Well, I'll show you guys in this first. The Java implementation of ANTLR has hidden in all caps. The C# implementation of ANTLR has hidden in proper property casing. Which means, in order to get rid of that error, I have to go back into my CGS.g3 and change channel equals hidden to channel equals hidden. You guys saw the difference, right? Just a quick side note to everybody. Every time you see curly braces in ANTLR, that means it's going to literally write this code out into the file it generates. Well, except for things that are prefixed with a $, which are handled specially. Okay, so what I just did up here on PowerShell is I told it to regenerate the file. Now if I jump back into my lexer, we no longer have an error. As you see, channel equals hidden is now the correct casing. So now that we have ANTLR generating our CGS lexer, our CGS parser, we can now create a test project that will test the output of our CGS lexer and CGS parser to be what we want it to be. Notice how I specified up here output equals AST. That means that all of these methods on my parser, if I look at my rules, like for example my style sheet, it returns a special class. That class is a parser rule return scope, which contains a tree. Now, if I didn't have the output equals AST right there, and I recompiled, look what happens to the methods. They now return void, which isn't very useful. It would only be useful if I injected C# code into my actual grammar. So make sure that you have the output equals AST. That way we'll be able to, so I just went ahead and recompiled. Now we can actually test the return of these methods. So let's create a test project and see about getting a tree tested against. Is it possible to create a macro or something to regenerate from Visual Studio? One of the things I wanted to do today, but we won't have time for, is writing a little tool that will scan a folder and perform the recompilation immediately on save. As far as any built-in Visual Studio support, there are a couple of projects and extensions that give you ANTLR support in Visual Studio, but be warned, they don't play nicely with ReSharper, and you get a bunch of horrible, nasty ReSharper errors, which is why I ended up going this route where I just generate the files using an auxiliary tool. So I'm going to have class library, and then I'm going to create cgs.tests. So here you go, solution. Here's your test project that you've been asking for since the beginning of the class. I'm going to add some NuGet references. First one I'm going to add is NUnit, because we need a testing framework. and we have NUnit. Then I'm also going to add a reference to Fluent Assertions, which is a nice little assertion library that I like using. So the first thing I'm going to do is I'm going to create a parser test. It's going to be a test fixture. And let's go ahead and create a test, public void test1. I know that's a horrible name for a test, but I just want to see about... Oh, come on. ReSharper is failing me right now. Or Visual Studio is. Notice how it's not highlighting those?
I figure why not? I mean, everything else has tonight.
Yeah. Okay, so when... A quick side note to everybody. When Visual Studio and ReSharper stop highlighting things correctly, close down Visual Studio, go into your source folder. Oh, wonderful. My ReSharper cache never got initialized. Huh. That's kind of weird. NUnit is the best or just your favorite? It's my favorite and it's the most widely used. Well, XUnit is pretty close to it as far as what I've seen from open source projects. However, every single thing that I use understands NUnit. Like, for example, TeamCity, which I use for... oh, there we go. TeamCity, which I use for continuous integration, has native NUnit support. ReSharper has native NUnit support. Honestly, there's a lot of great features in NUnit, and there's a lot of great features in other testing frameworks, but at the end of the day, they are really rather boring pieces of software that do pretty much the same thing. RhinoMock, I don't... If I need to do mocking, I use MOQ, which I don't know how to pronounce. I've never used RhinoMox before. Okay, so here's my test1 test. I know it's a horrible name, but I just want to see some stuff happening. So I'm going to hit run test, and this test should pass, but I just wanted to run it so I can get my window. Let's put my window right there. Okay, so what I'm going to go ahead and do is I'm going to go into the CGS compiler, and I'm going to add a method that will allow me to reach into the classes that ANTLR generated for me and invoke their methods that ANTLR created. As you'll see, these things like style sheet, this is a private method. There's no way for me to publicly access this method. However, fortunately, ANTLR generates all my classes as partial, which means that I can provide another partial class, which I'm going to do outside of the compiler. I'm going to create a CGS lexer. Whoops, I wanted CGS parser. And I'm going to make it partial. Now, unfortunately, you'll notice one quick thing. This partial definition doesn't line up with this partial definition. The reason is this class is not in a namespace. Fortunately, that's very easy to fix inside of ANTLR. I'm going to go back into my grammar file, and at the top, near the top of the file after my tokens, I'm going to say parser namespace cgs.compiler, and then lexer namespace cgs.compiler. Then I'm going to have ANTLR. What I'm doing up here is I'm just rerunning the same command over and over again, by the way. Which, and I just arrow shook every single window away. I hate arrow shake. Where did my PowerShell window go? There it is. Okay, so if you want the command, there it is. But anyway, now that we've done that, if I look back at my CGS parser, you'll see it's now in a namespace. And because it's now in a namespace, I can now extend it through the partial definition. Next thing I'm going to do is I'm going to tell ReSharper to add CGS to my abbreviation list, so it doesn't complain about those names. Now what I'm going to do is I'm going to write a method that's publicly accessible that will allow me to get what's called a common tree. So let's go ahead and do that. I'm going to say public common tree compile that returns common tree style sheet dot tree. This public method reaches into my style sheet method, which ANTLR wrote for me, and then grabs out the tree, which, because I didn't override which kind of tree that ANTLR is using, it's using what's called a common tree. Now that I've done that, I can go back into my test project. I can add a reference to my compiler through my solution references. I can instantiate my parser. I can say bar parser equals new CGS parser. And I now have to pass in a token stream input. The great thing about that is all we have to do is instantiate a new... Hold on. We need a reference to the ANTLR runtime. As you see right here, it says module ANTLR3.runtime should be referenced. So let's go ahead and do that. Hope I'm not going too fast for everyone, but I do want to get this stuff going. Okay, I'm going to instantiate a new common token stream, and a common token stream needs an iToken source. Fortunately, there is something of an iToken source that we have generated for us by ANTLR, and that's our lexer. However, our lexer needs an iCharacter stream. Fortunately, we can instantiate a new ANTLR string stream and pass in a string input into it. The input I'm going to pass in is going to be test color red. You can tell that ANTLR was originally written for Java by the amount of classes I have to instantiate in order to get this working. But anyway, now that I've instantiated my parser, the great thing about it is that I now have a compile method. So I can say var tree equals parser.compile. Then I want my tree to string tree. To string tree will return a string that looks like this. So what I want to do is I want toStringTree to say should be, and my D&D turned off again. Give me a sec. Should be, and then it's going to be, let's see what we should do. Let's just start with something simple. Test color red. I don't know what it's really going to look like, but when I run this test, it'll tell me what it expected and what actually got outputted. It says expected string to be this with a length of 18, but was .test color red and has a length of 24. So now that I've done this, I can now get into the fun bit of ANTLR. Actually, I think ANTLR is quite a bit of fun, even just the stuff that we've been doing with lexers and parsers. But we were missing one very important step. And that very important step is that we're not actually instructing ANTLR how to take our grammar and turn it into an AST, or an abstract syntax tree. Right now, what it's doing is ANTLR is printing out a tree. Actually, I can go ahead and inspect it for you guys if you want to see it. Here, this is what ANTLR produces by default. It produces a tree that, oh, don't tell me you're not going to give me, there we go, that has children of every single token that it read. Now this is not good for two reasons. First of all, this isn't a tree. This is just a list of everything that ANTLR read. And second of all, we have a lot of tokens that we don't care about. We don't care about semicolons or curly braces. And this .test, we want this to be combined into the concept of a class selector. So this gets into one of the bits of ANTLR I had the most fun with, and that's telling ANTLR how it should go about turning our token stream into a abstract syntax tree. To do that, there's a variety of, well, just like with anything with ANTLR, especially anything with Java, there's a variety of ways of doing it. There's the simple way of telling ANTLR to ignore a particular token, and there's a more complex way of providing a transform rule. And we're going to be using both of them. So let's go ahead and take a look at a simple example. I want my curlies to go away. So I am putting a explanation point up there. I'm going to recompile. And actually, sorry about that. I think they're at the end of it. There we go. Now that I've recompiled, let's see what our syntax tree looks like. Now our syntax tree looks like this. Or, sorry, this. Notice how our curlies are now ignored. By adding in that explanation point at the end, it tells ANTLR that we do not want this token in our AST. So let's give the same treatment to our semicolons on identifiers. So now if I go ahead and recompile and rerun, notice how our semicolons no longer appear. And let's do the same thing with colons. We don't need those either. And run again. And now we have this. But this still isn't very useful. And one of the reasons it's not useful is we don't have any concept of nesting. What I want to do is I want to turn a rule into a tree structure. But at the moment, ANTLR doesn't understand how to turn it into a tree structure. So I just wanted to demonstrate how we could use this syntax to modify our ASTs, but there's another way to do it. And that way is by, at the end of the rule, providing this little arrow syntax guy and giving it a complete rewrite. Now, these two methods of rewriting ASTs do not work together, meaning if I provide a complete rewrite rule for my AST, I cannot use the explanation points to remove these tokens. So I'll remove them because that will cause a compiler error from ANTLR. And instead, I will provide ANTLR with the way I want this AST to be written. The way I want it to be written is I want me to have a rule. So this is where things get really fun. By the way, if people are still, awake. I don't know if people are awake by now. But this is where, I'm sorry, I really have lots of fun with ANTLR. What I'm going to do is I'm going to create a token up here in my tokens declaration. But guess what? It's not going to equal anything. And you might ask yourself, why would you want to ever do this? And the answer is, I want to create an AST that has tokens that don't actually match to any physical text in my file. I want them to add additional semantics to my AST. So what I'm going to say is, I want this to be a rule token. Then, after the rule token, I want it to have my selectors. After my selectors, I want it to have my declarations, which I'll get into in a moment. Declarations are actually the fancy term for what this is. However, I now need to turn this into a different rule. I need to turn this into a declarations rule. The reason I need to do that is because of the way the rewrites work. So, I want my rule to turn into this tree. So now when I hit, whoops, I forgot to recompile. Alrighty, I'm getting a syntax error on line 31. It's complaining about no viable alternative at input alt, referenced undefined rule selectors. I beg to differ. Reference undefined rule declarations. Hold on, I might be doing this wrong, but I'm sure I'm not. Actually, I think I might have to do that, which I didn't want to do yet. Yep, that worked. I was actually trying to prove a point about how ANTLR AST rewrite rules work by not introducing this caret, because this caret is very important. But now when I run, this is what we get. We get rule, then dot test color red semi, which is a lot closer. Notice how this rule didn't exist before. So that's really cool. The reason I had to add this in is because you'll notice that our tree now actually does look like a tree, kind of, sort of. Check this out. If I open up my tree is now a rule, and it has children inside of it. If I look at my children, I now have all my children inside of there. Well, guess what? If I were to do another one, like if I have two rules, one with a class selector of test2 and a background of blue, and I run it now, and I take a look at what my tree looks like, notice how we now have nesting. We now have an actual tree. We have a tree that's nil and has two children. Those two children are rules. This rule contains every single token that was parsed inside of that rule. This rule contains every single token that was parsed inside of that rule. The reason we now have this behavior, the reason we actually have a semblance of a tree, is because of this symbol right here. This symbol tells ANTLR that we want to nest every single thing that it finds in here into a parent tree node. So that's really cool, but we're still not exactly where we need to be. If you look at the compiled AST, you know, that's cool, we have rule, but we still have this dot test color red blah blah blah. I don't want that. I want to introduce the concept of a selector into my AST. So I just added a selector token. Again, this is a token that has no correlation to my text at all. It's something that I am inserting into my AST as it gets compiled. Now, what I want to do is on my selector, I want a selector, and then I also want a class selector, and an element selector, and an ID selector. So I want my selector, class selector, ID selector, and element selector. Then on my class selector, I want to turn my class selector into class selector of ident. So what this is going to do, and I also want to turn this into, I want this to be parented to an additional node, so it's easier to parse. What I'm doing now is I'm rewriting, again, this is a rewrite rule. This is rewriting this token stream into this tree. And this tree has a new token inside of it called class selector, followed by the identifier that it matched. Meaning now when I run, look what happens. Oh, derp. Every single time I'm going to forget to recompile the tell ANTLR to recompile it. But anyway, check this out. Now it says rule. Then inside of a nested object, which is finally a tree now, it's no longer just a flat list, I now have class selector of test. So that's awesome. Let's go ahead and give the same treatment to my ID selector. And let's give the same treatment to my identifier selector or element selector. Now when I go to parse my AST, I can now differentiate between what a class selector is, an ID selector is, and an element selector is, without having to know anything about the language. See, it's this one grammar file is what determines what my language turns into. It understands that a hash followed by an identifier means it's an ID selector, but the code that's going to be depending on this grammar does not. The whole point of this grammar is to turn it into an AST, which again stands for abstract, emphasis on the abstract, syntax tree. It's not a one-to-one mapping to the text I have in my file. So the next thing I need to do is I'm going to go ahead and inside of my selector, I'm going to rewrite this to, again, this selector followed by my selector type, which by putting selector type right in here, it will put whatever was returned by this rule, and what is returned by this rule will be something like this or this or this. So I'll do selector, selector type, followed by my pseudo selector, but I'm going to make that optional, followed by my child selectors, which will be 0 to many. Now my pseudo selector gets turned into, or will get turned into, something like, let me go ahead and normalize this formatting real fast. Pseudo selector is going to get turned into something else that can be understood, which, let me go ahead and copy that, blah, 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 and then uppercase this, which I totally forget what the keyboard shortcut for uppercasing something is. Make uppercase, pseudo selector. So now we have a pseudo selector token, and my pseudo selector is going to turn into simply a pseudo selector. So it's turning something that has no semantic value, colon followed by identifier, which could mean a million different things, and it's turning into something that can be understood directly by whatever it is that's going to be understanding this. However, I want to show everyone a magic trick. Actually, after I show you guys what the output of this is. So if I say test hover li and run after I compile, hey, I remembered this time.
Amazing.
I'm going to hit run, and let's see what we get printed out to us. We get a rule, then underneath rule we have a selector that has a class selector of test, a pseudo selector, and an element selector of li. So that's actually really cool what we have right there. However, we have a problem. We have just lost information. We lost information because we took this stream and we turned it into this. We never grabbed the value out of my identifier, so we don't know what pseudo selector we're actually using. Remember, the identifier of the pseudo selector is what appears after the colon. We need that information to know what pseudo selector we are representing. So ANTLR provides a neat little trick. If inside of here I can put in expressions. I can actually put in what these square brackets do is it actually changes the way that this token class is instantiated, which is neat, which means I can pass arbitrary information into the constructor of the token class. In fact, I can show you guys what that looks like. If I go into my generated parser and I look at my pseudo selector, oh, come on. Don't be like that. Here we go. What we have right here is my return value is right here. Notice how it does this. It does an adapter.create. Well, keep this in mind because we're about to change what code goes in here. What I want to do is I want to place the value of the text of identifier into the text of this new token. And I can do that by doing $ident, then $ident.text. The reason I have to pass in two things is because the first parameter to the constructor is the location information of where this thing appeared in my text file. So the great thing about ANTLR is it carries on information like what character or what line a particular token appeared on. And by passing it into the first parameter of the constructor, it will take that information, copy it into the new token I'm instantiating. The second parameter is the text of the token. So I want to copy both the location information and the text of the information into my pseudo selector. Now when I run this, so notice this is what it looks like right now. It just says pseudo selector. Now when I run this, I actually don't know if it'll show anything different without... Oh, there we go. Now it says hover. Now it still is a pseudo selector, but now it has text in it. And because it has text in it, ANTLR, when I do the .to string tree, it will print out the text. Now if I went into the debugger and showed you, well, I can just do that. for you guys, because inspecting this sort of stuff is very, very important to be able to understand. So here's our tree. Our tree has two children because we have two rules. Our first rule has some children in it, has a selector child. Our selector rule has a class selector and then hover. Notice how this is my pseudo selector right here. If I open up hover, notice how its type is set to 17. 17 is, if I go into the code file that ANTLR generated, 17 is the number that represents a pseudo selector. So notice how now I have the type of selector it is, which is pseudo selector, type 17, and I also have what text was included inside of it. Now I can also show you guys, check this out. Remember that code I told you guys to take a look at? Well, now we have a different parameters being passed in to my create method. And those parameters pull the text out of this identifier and place it into my pseudo selector, which is really neat. Okay, so I was doing something. What was I doing? Let's take a look at how far we are now. We now have my rule, selector, class selector, test, my hover pseudo selector, my element selector. So actually we have everything but our properties. Notice how our properties are they still don't know what to do. They still just get dumped out as arbitrary tokens. ANTLR has no idea what to do to them besides just throw them at my tree. So I got to tell ANTLR how I want to organize these. It'll make a little bit more sense if I added in one more property into my declarations. It'll make a little bit more sense when I modify how this gets generated. So if you remember, this part of the tree gets generated by my declarations rule. I want to take my declarations and I want to convert it into something that has the ident and the value. However, I don't want to pull over the ident word for word. Instead, I want to give it another semantic token. So I'll go ahead and create a property token. And I'll say property, passing in the value of ident, the value of ident.text. Then after that, I'll pass in value. Now, again, it's very important to note this guy right here, this symbol. Let's go ahead and compile this. See, make sure it compiles. Okay, it compiles. Let me see if it compiles without this. Because if it does, it would be a great demonstration of what exactly that does. Oh, we got it to compile without the thingy, which means I now run this and you'll notice something wrong. See how it says color red, background blue? Remember, it's pulling out color. Color is actually a property token, but it's just displaying it as its text. Remember, if I didn't put in the text of it and I just said property, and I hit run, look what it does right now. It says property red, property blue. But I'm overwriting the text of that token. But you'll notice a problem. When I go to actually parse out my AST, how do I know that one property ended and one property started? Well, the whole point of an AST is that it's an abstract syntax tree, which means it's a tree structure that I can annotate in any way that I want. By adding in or adding back in my caret thingy and my parens, it'll generate it slightly differently. What it's going to do is it's now going to turn these into children of that tree. So now what I have is that, which I can then actually go ahead and parse and do something useful with. This is very easy to parse. And next week we'll talk about tree grammars. Tree grammars are a different type of grammar inside of ANTLR that allow us to parse these trees that the other grammars create. So that's all pretty cool. what I'm going to do is I'm just going to cheat here. Because this is exactly what I want it to do, I'm going to cut this or copy this, and I'm going to paste it into my test. There we go. Now it'll work. But this is, again, exactly what I want it to look like. So now, I'll go ahead and call this test nested element pseudo basic properties. There we go. Now let's make another test, just to make sure that I can reliably handwrite the appropriate tree, which is a good thing to do. So let's go ahead and make a test that has 4 child selectors. What I am going to do actually is I'm going to take this, my parser, and I'm going to abstract that out into a private common tree parse CGS string input, and then I'm going to take U, cut U, input var tree equals parser.compile return tree. Now I can say var tree equals parse CGS passing in my string. So that makes it so I don't have to rewrite this every single time. In fact, I could just inline this variable entirely. There we go. That looks good to me. So let's go ahead and write another one. Parse CGS. Let's do a class selector followed by an element selector that has a pseudo state of hover, followed by a UL and then an A tag, and its color is blue. So let's handwrite what the tree should look like given this input to make sure that we completely understand what exactly is going on. Well, the first thing is that we need a rule. Next up, we have selectors. Next up, we have a class selector, a value test. Next up, we have another class selector with a value, or an element selector, sorry, value of h1. Now, this element selector, well, immediately after the element selector, we'll have a hover. Then we'll have another element selector with the value of ul. And then another element. Actually, let's change this to an ID. Honestly, this is the stupidest CSS rule I've ever written, but it's just there to prove a point. ID selector bleh. Now, followed by a color of blue. And then we'll annotate this as a test. And then I'll add this to my current session, and let's see what happens. Okay, how close did I get? Oh, I'm missing in parentheses. But you have to admit that was pretty impressive, right? Jason?
Yeah, I guess. I mean, if you want to call it that.
Well, I handwrote an entire AST and got it right in the first try. But anyway, I just wanted to write a couple tests just to make sure that if we ever break anything with our parser down the road, we'll be immediately informed of it. Do you think they have time for, or we have time for another 10-minute thing?
Yeah. I mean, they can always watch the video later.
Yeah, but I'm having fun here.
Go ahead.
Okay, let's write a tree grammar real fast, just to show you guys. Now that we've gone through, this process of taking this text, turning it into this token stream, turning it into this tree, we now need to take this tree and turn it into actionable logic. So let's do that. I'm going to create a new item, code file. I'm going to call it CGS tree.g3. Now, remember at the top of this we said grammar CGS? Well, at the top of this I'm going to say tree grammar CGS tree. Then I'm going to give it some options. language, what did I use before? C#3, that's what I want. Let's do AST label type equals common tree. That's telling ANTLR which tree implementation to use. We can write our own custom trees if we wanted to, but I'm just going to use the built-in one. The next one is token vocab. This is important. The token, remember how I invented a bunch of arbitrary tokens up here? Well, my tree grammar is going to need to know how to parse those. Now, because these two files are not within, don't know about each other, they need some sort of common point of reference. And that common point of reference is generated for us by this file. This file tells us what our tokens are. And this file is generated when we compile our CGS.g3. Then when we compile our tree grammar, we have to tell it which token vocab to use, in this case CGS. So what it'll do is it'll look for a cgs.tokens file and use that as the token vocab. Okay, let's go ahead and give it a namespace real fast of, how did I format that before? I want to be consistent with my formatting. Let's give it a namespace of cgs.compiler. Then let's go ahead and create a style sheet rule. Style sheet rule is a rule and then an EOF. Now, what's a rule? Now, this is where things get fun. This tree syntax that I'm writing right here is very similar to this token, this other syntax that I'm writing here, or that I've written here. The difference is that these parser rules are matched against these lexer rules. So the result of these lexer rules get fed in to these parser rules. The tree is different. The result of these transformations get piped into my tree. So I'm going to make another rule, which you'll notice is very similar. But the cool thing about it is that when I match it, guess what I have to do? That. So I'm not matching against the blah, blah, blah. Yeah, solution, I've already written something like that. But yeah. So we're matching this. And then after we match this, we got to do something to it. So what I'm going to do is I'm going to keep things relatively simple. I'm going to say rule is a rule token followed by selectors followed by declarations. What's selectors? Well, selectors are just selectors followed by selector plus. And then what's a selector? Don't worry, things will get interesting soon. A selector is, what are we matching against? We're matching hold on, I just want to paste this in right here so I can take a look at it while I'm writing this. So first we're matching rules. Rules have a collection of selectors and then a collection of declarations. Then we have selectors. A selectors is the selector token followed by multiple individual selectors. Now, an individual selector could be something like a class selector or a pseudo selector. So let's figure that out real fast. A selector plus a selector is going to be, now I'm confusing myself. But don't worry, I'll figure it out. Blah, blah, blah. These are selectors. Okay, so what we're matching actually is this. Right here, we're matching that. Yep. And then what's a child selector going to turn into? A child selector. This will all make sense in a second why I'm copying and pasting this code over. A child selector is a selector type followed by an optional pseudo selector. And a selector type could be a class selector, ID selector, or an element selector. So we have selectors. I'm saying that word so many times, it's starting to, you know when you say a word so many times, it starts to sound like not a word? You have that feeling?
Oh yeah, been there, done that.
Alright, well let's leave this relatively simple. I want my selectors to match this, then they can match a nested element selector, class selector, Okay, let's make this simple. Selector type can be an element selector, a class selector, or a ID selector. An element selector is going to be this element selector followed by an identifier. Our ID selector is going to be this, and our class selector is going to be that. Okay, so now we have a selector type followed by a pseudo selector, which a pseudo selector is turned into this guy. So a pseudo selector is literally just the pseudo selector token. So I don't need to do anything special with that guy. Then we have our child selectors. Our child selectors look like selector type followed by pseudo selector. Okay, so that will match these rules. Again, we're starting with just matching. Just like we did with our original grammar, we started with just being able to match our input and see it turned into a tree. That was the first step. And that's what we're doing right here. The first step is just to match our tree with our tree grammar. The second step will be actually to do something with our tree grammar. So finally, all I have to do now is do my declarations, which I don't like how I pluralized that. That should be declaration, not declarations. Now a declaration is just a... By the way, these names do not have to match. I'm reusing the same rule names as my other grammar, just for consistency, but they do not need to match at all. I could have written my tree grammar in a completely different way that I wrote my original grammar. So, here's my declaration. My declaration is a property followed by a value. What's a value? Value is an identifier. So instead of doing property by value, I'll just do property by ident because I'm lazy. Okay, let's see if this compiles. Then I'll throw in some fancy stuff and we'll be on our way. So I'm going to actually open up another PowerShell window. First going to recompile that to make sure. Reference to undefined rule declarations. Hold on. Whoops. There we go. Okay, now I'm going to change directory into this. Oh, you have to be quoted, seriously. And then I'm going to basically run the exact same thing that I ran before, except for, whoops, I didn't copy it hard enough. There, I copied that. Except for we're not doing cgs.g3, we are doing cgs.tree.g3. Hey, look, it compiled. Now let's take a look at what it generated for me. I'm going to again hit the button on my Solution Explorer to show all files. And then I'm going to right click on both of these and say include in project. Now I'm going to open up CGS tree and take a look at it. Notice how it doesn't return anything. It just says private void style sheet blah blah blah. Well, that's not very fun. What I'm going to do instead is I'm going to, in my just to complete this example, yeah, here's my CGS tree.g3. What I want to do, the way I'm going to use my tree grammar, this is a very common way to use ANTLR. I've already had ANTLR generate a file that is capable of reading my tree. But what I'm going to do now is I'm going to insert actual C# code directly into my methods that ANTLR generates for me in order to do something. What that something is completely up to me as the programmer. So let's go ahead and do that. When we match a rule, what do I want to happen? Well, keep this simple. I want system console write line in rule. When we hit a declaration, let's go ahead and say dash dash 0 equals 1. 0 is going to be property.text. 1 is going to be ident.text. When we hit a element selector, I want to say £0. £0 is going to be ident.text. Notice how I'm extracting out the things I matched, just like how regular expressions work with grouping. Inside of my ID selector, let's go ahead and do the same thing, but oops, my element selector I don't want to prefix with the hash. My ID selector I do, because that's the CSS syntax of it. And my class selector I want to prefix with the period. My pseudo selector I want to prefix with the dash, and I'm going to say pseudo selector.text, which will pull out the kind of pseudo selector it is. And I guess that's really about it for now, just to do some simple testing. Now I just recompiled my tree, but guess what? We now have stuff like this injected into CGS, or into our rendered out class. So this is how I actually originally, or did build CGS. It's a very good way to do it. You have your lexer and parser that understand the language. They convert it into a tree grammar, or a tree that's understood by my tree grammar, and then my tree grammar executes arbitrary C# code when it runs into something. So let's wrap up today with a really basic, I'm going to create a file called, a class called CGS tree. I'm going to make it public and partial. And I'm going to have a public void do things. Do things will simply invoke the style sheet method. By invoking the style sheet method, it will initiate the whole recursive descent parser that is my CGS tree grammar. Now I'm going to create a console application, just because. I'm going to say cgs.console. I'll probably be deleting this project at some point, but I figured it'll be nice to show people things every now and then. I'm going to add a reference to my ANTLR runtime, and I'm going to add a reference to my CGS.compiler. Then I'm going to spool up my CGS tree. So how do I do that? I say var tree grammar equals. Now again, this is where things get a little annoying. As you will tell, this is definitely written by people who like Java. New CGS tree. It has a iTree node stream parameter in its constructor. Fortunately, there's a common tree node stream. Common tree node stream needs an iTree adapter, which fortunately there's a common tree adapter. Common tree adapter. Oh, wait a sec. Ignore me. We actually pass in our tree right into the common tree node stream. So we need to get our tree. How do we get our tree? Well, we instantiate. I'm actually going to do this on a separate line. Var tree equals new CGS parser, passing in a common token string, passing in a CGS lexer, passing in an ANTLR string stream, passing in. I want to pull in one of my more complicated examples. And then I'm just going to call this parser. Parser equals that. Tree equals parser.compile. Tree goes into the tree grammar, and then I say tree grammar dot do things. Console.read key. Read key. What? Oh, namespace collision. System console.read key. Now when I hit run, I get an error because I didn't tell my console to be the startup project. Now when I hit run, I'll get another error because I'm missing a semicolon. Now when I run, It doesn't like text. It doesn't like my pseudo selector for some reason. Give me 1 second. Let's look at my pseudo selector. Pseudo selector. Ah, I forgot the $sign. The $sign is what will associate this object to what this object was matched to. So now I'll go ahead and recompile everything. Hit F5. Take a look at that. Actually, I'm going to reverse the end roll. I want the end roll to happen before it descends. And then, just to be fancy, do that. And then I can say that is fine. I'll just put in some words. Element selector, ID selector, class selector, recompile, hit F5, and take a look at that. If I go back to the code that I told the CGS parser to parse, I have a rule. The rule has a class selector of test with a pseudo selector of hover, followed by an element selector of li, followed by color equals red and background equals blue. That's the end of this rule. The next rule has a class selector of test2 with background equaling blue. So is everybody suitably impressed? I mean, come on, I thought it was fun anyway. Yeah, but programmers get excited about weird things.
This is true.
But yeah, so basically what you guys have seen is a really, really quick and dirty rundown of an end-to-end custom language written in ANTLR. Obviously it doesn't do anything yet, but it will, because all we got to do is what I did with CGS originally is inside of my tree grammar, I instantiated objects that represented my interpretation or my internal representation of CGS, and I did those inside of these actions. They're called actions. Now there's a lot of other fun things you can do with actions. You can do scopes. For example, scopes are lots of fun, and all sorts of other cool stuff, but we don't have time for that. Right now we have a very incomplete language, but it does actually at least demonstrate how ANTLR fits into everything. So yeah.
Yeah.
Stuff.
And things.
And things. Okay.
But you saw the question about the Unity GUI, the connecting.
So how far from connecting this to Unity GUI stuff? 2 weeks? We'll see. Because there's a lot of CGS that has nothing to do with Unity. We have the bare bones of a language here. It doesn't do much, but we have, actually, to be honest, we do have quite a bit of CGS already implemented, but not everything that I want implemented. We don't have like numbers or colors or resources or anything like that. What we need to do next is, now that we have some basic rules going, next week I want to flesh out the language a little bit more, get proper values set up, and get other things working. Then we'll have to start looking at the actual internal in-memory representation of CGS. We'll have to start figuring out, okay, so what is a selector object and how does it work? How does it know if it's selecting an element and so on? After we have that, we then have to create the properties that we want to support with CGS, such as like width, height, margin left, margin right, blah, blah, blah. Then, after that, we can then hook that up into Unity. The hooking up into Unity part will be probably the easiest aspect of everything that we've done here. And if you wanted to hook this up to NGUI, I mean, sure. There's nothing stopping you. So far, as you'll see, the majority of CGS is code that could be applied to anything, any environment. We'll also see later down the road how to package up Unity or CGS If you guys want to see a little, you guys want to see a little spoiler of that? Where am I going? Now, unfortunately, you'll notice that CGS has a lot of references. If I even went into cgs.unity, if I look at the bin folder, look at all of these DLLs it has to reference. It has to reference the ANTLR through runtime, CGS base, compiler, engine, properties, Unity, and Unity engine, and log4net. So one of the fun things that I actually did with CGS that we're going to be doing at the end of this entire process is showing you guys how to use Rake to create a build process that actually merges all of those DLLs into a single one. Now, there's two here because this is the non-Unity version, this is the Unity version, and then I also have log4net out of there. But yeah, you get the idea. So we will look into some cool build processes and stuff. Which I don't know if I'll still use Rake. I mean, Rake is easy enough to use, honestly, but it is Ruby. So, again, there's a little spoiler for that. But that was fun to write. I might use another build system. It doesn't really matter. The point is that packaging things and combining DLLs is lots of fun. Rake is the same thing as Ant. Yes, Rake is basically the Ruby version of Ant. And there's something called Albacore, which is a Ruby gem that hooks into MS Build, so you can use Rake to compile CS projes and the like. So yeah, I think that's just about it. Again, this is a good start, but not a whole lot happens at the moment. But we at least have all of ANTLR pretty much figured out, or at least an end-to-end process of using ANTLR to do what we want it to do. So I hope everyone had fun and stuff.
Good stuff, man.
So yeah, unless you have anything else you want to say, Jason.
No, not at all. That should wrap it up then.
Alrighty, so goodbye.
Bye, everyone. We'll see you guys.